Assalamu alaikum students, this is Farba Batul, your O-level computer science instructor, and welcome to another video of chapter number 10, Boolean logic. In the previous videos, we are done with example number 1, 2, 3, 4, 5, 6 of your book, and now in this video, we will be doing example number 7. So I will be working in detail. There is a problem statement in example number 7 which says that a wind turbine has a safety system. Look over here. A wind turbine has a safety system which uses three inputs to a logic circuit. A certain combination of conditions result in an output X from the logic circuit being equal to 1. When the value of X, which is the output, equals to 1, then the turbine is shut down. Okay. The following table shows which parameters are being monitored and form the three input to the logic circuit. Look over here. This table is very important. According to this table, there are three parameters, or we can say that these are the three inputs to our logic circuit, and each input has two values. Either it can be 0, either it can be 1, because we are dealing with binary data. So binary values can be 0 or can be 1 for one single input. Now, it's already mentioned here that if the value of S is 0, it means that the turbine speed is less than equals to 1000. And if the value is 1, then the turbine speed is greater than 1000 RPM. So this S is basically the speed of the turbine, and the value of S 0 or 1 determines that what is its speed. Now the next parameter is the temperature, bearing temperature. So the temperature, if it is 0, the temperature is less than equals to 80%. If T is 1, then the temperature is greater than 80 degrees centigrade, not percent, degree centigrade. So this is the parameter of temperature. According to the value of T, we will determine that what would be the temperature. Now W is the wind velocity. Okay, the velocity, if it is 0, it means it is less than equals to 120. And if the W, input value of W is 1, then we can say that the wind velocity is greater than 120 kpm. Now, with the help of this temperature, we will be making the logic expressions for each of the given conditions. Look over here. The output X will have a value 1 if any of the following combinations of conditions occurs. Okay, so these are the three conditions. If either of these conditions are going to be 1 or going to be true, then only your wind turbine will shut down. Okay, so for the value of X equals to 1, we have three conditions: 1, 2, and 3. And remember that it's written or in between these three conditions. So if any one of these conditions becomes true, the wind turbine will shut down, or the value of output becomes 1. Now what you have to do for this example, you have to design a logic circuit and you have to complete the truth table to produce the value X equals to 1. Okay, when either of the three conditions above occurs. So first of all, it is very important to write down the logic expressions for these three conditions. Logic expressions. Okay, so for the first condition, let's see the condition here. First condition says that turbine speed. Look at the parameter of turbine speed. It is represented with input S. So we will be writing turbine speed less than equals to 1000 RPM. It means if we see that turbine speed is less than equals to 1000 RPM. Here the value of S is 0. So we will be writing not S. Remember that the input will be written with not only if the value of input is 0. Just we have seen in the previous example. And if the value of input variable is 1, then we will be writing it like S. Similarly, here the value of t is 0, so it will be written as not t. And here the value of t is 1, it is written as t. Same goes for w. It will be not w and it will be w. So in the first case, turbine speed is less than equals to 1000 rpm, which is the first one here. So we will be writing not S. And then there is and. The word and means that you have to add and logic gate between the two given conditions. The other condition is bearing temperature is greater than 80 degrees centigrade. So look at this. It's over here. The bearing temperature is greater than 80 degrees centigrade. So it is the value of T is 1. So write down T as it is. By the help of table, you will be writing your logic expressions. Now number 2. In the number 2 condition, turbine speed is greater than 1000 rpm. Let me clean this for you. Okay. So in this one is correct. Turbine speed is greater than 1000 rpm. So it means we will be writing S as it is and we will write and with this input because it's written and here. Wind velocity is greater than 120. Look over here. Greater than 120 kpm. So it's just W because here the value of W is 1. So we will write W as it is. For the third condition, look over here. Bearing temperature is less than equals to 80 degrees centigrade. So for this case, quickly see that it's matching over here. Bearing temperature is less than equals to 80 degrees centigrade, which corresponds to not T. Not T means the value of T is 0 over here. So write down not T, then put an AND operator and wind velocity greater than 120 kpm. So it's over here. This corresponds to W because the value of W, input value is 1. Write W as it is. So this is what we have done so far. We are done with 3 conditions and their logic expressions. Now, all these conditions are connected through OR. Look over here. It's written either or. So it means the final expression will be like this. In the final expression, all of these 3 conditions will be connected with OR gate. Not S and T. This condition number 1 will OR with the second condition. Second condition is S and W. And this is going to be OR with the third condition. Because either of these 3 conditions becomes true, then the output X will be 1. Even if it is 1 and it is 0, 0, the output will be 1. If this one is 0, this one is 1, the output will be 1. And if this one is 0, this is 0, and only this one is 1, the output will be 1. So this is what an OR operator does. An OR operator is saying that if any of these conditions are true, any one, then your result, the value of X will be 1, true. Okay, so this is our final logic expression. Now let's quickly make the circuit out of this logic expression. Okay, so the circuit, first what I will be doing, I will make a circuit for this. Okay, it is when S is going through a NOT inverter and T is going directly to an AND gate. So make an AND gate. S is going through inverter. It is not S or S bar, and T is going directly. This is for the first condition. For the second condition, look over here. S and W are going directly to an AND gate. This is S and this is W. For the third condition, T is going through an inverter and W is going directly through an AND gate. This is T and this is W for the third condition. So this is 1, 2, 3. Now we will be combining these through an OR gate. So look over here. Now quickly combine all of these three logic circuits through an OR gate. First we will combine, it is a step-by-step procedure. Combine these two conditions through an OR gate, and once we are done with this, then we will combine the third one. How we can do that? S will go directly and T will go like this through an AND gate. And in the next AND gate, look at this. S is going directly, so we will make a dot and S will go like this. And W, sorry, the next one is W. W is going straight away like this through AND gate. This is how we combined condition number 1 and 2. And since there is a OR between these two conditions, so the outputs of these two gates will go straight away to the OR gate like this. Once we are done with this, now we will combine this with the result. Or in other words, the third condition will be combined through an OR gate with the result of the first two conditions. Let me just explain you this thing from the logic expression. So look over here. We are done with this part. We have connected the two conditions with an OR gate. And now we need this one to be done. So what you will do, you will connect this whole with this through an OR gate. So first make this one, make the third condition, and then you have to connect it with OR gate with this whole circuit, or in other words with the output of this circuit. So this is one input for the OR gate and this whole is the other input for the OR gate. So it means that now the third condition says that T, you can make a dot over here, and T with an inverter is going to an AND gate. Look over here. And W is going directly. So put a dot here. I'm just cleaning this to make the circuit clear for you. W will go directly to a AND gate. Be very aware of the inputs that you are providing to each of the AND gates. So once it is done, now you will be connecting the result of this AND and this OR together. So here will be another OR gate like this. This is what I wanted to explain you, that this is your first AND gate. This is condition number 1. This is your another AND gate. Both of these condition number 1 and 2 are combined together with a OR gate. And then the third condition is over here, which is whose output line has become the input of another OR gate. So here you will be using two OR gates because look your logic statement. You have done with this and this, combined condition number 1 and 2 through an OR gate, and then the whole result of this is combined with the third condition through another OR gate. So this is what we have done. Let me just make it very clean for you and then we will work on the truth table. Okay, so far we are done with logic expression of this problem, and also we have designed the logic circuit. Now what next? It's time to make the truth table. So there are two options for us to produce a truth table. Either you can use the logic expression or you can use the logic circuit. So what I will be using the method of your book, and that is producing a truth table from the logic expression. So I will copy the same table and I will fill the values by myself to make it understandable for you. Second thing is logic socket. Miss Wahida and Miss Donna, your certificate. Let me just quickly tell you that I will be following this method of producing a truth table. Okay, so here we go. This is the logic expression, and this is the truth table that I have pasted from your book. The values are already deleted, and I will fill it according to myself. Now, in this truth table, look at this. I have made the three columns for input values. STW, there will be 8 input combinations since we have 3 inputs. 2 raised to the power 3 equals to 8. That's why you have 8 input values. Now, the other 3 columns are representing the conditions. Look over here. This one is first one. S and W is the second condition. And this one, not T and W, is the third one. Once you are done with this, then the fourth condition is basically the OR operation between this and this. So I'll show you one by one how we can do that. This is the fourth is basically the result of OR operation between first two conditions, and this final output is going to be the OR operation between the fourth value and this third condition, this one. Okay, I will clear it for you. Let's start the working first. In the first column, you have to work for condition number 1, which says that not S and T. It means the value of S must be not S, not S or S bar. So once we need to work on this condition, we need to make all the values of S inverted. Inverted means if S is 0, make it 1 just next to S, so it will be easier for you to work. This is the values for S bar. S is inverted. S bar means not S. You have to do the multiplication between not S and the values of T that are just in the second column. So when we will multiply, look at this. 1 into 0 is 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 1 is 1. Just look at these two columns. 0 into 0 is 0, 0 into 0 is 0, 0 into 1 is 1, 0 into 1 is 1. This is done. For the second condition, you have to do S and W. S and W means that there is no need to have not S. It's simply S and W. So you have to consider the column of S here and the column of W and produce a multiplication between them. So 0 into 0 is 0. 0 into 1 is again 0. 0 into 0 is 0. 1 into 0 into 1 is 0. 1 into 0 is 0. 1 into 1 is 1. 1 into 0 is 0. And 1 into 1 is 1, like this. I'm really, really sorry. I just made one mistake in the previous calculation. That is why I say that you need to do the work very, very, like, you have to pay attention in doing the work. So let me just quickly do for the first column. S bar was 1, 1, 1, 1, 0, 0, 0, 0. Let me quickly do for the first 1 into 0 is 0, 1 into 0 is 0, 1 into 1 is 1, 1 into 1 is 1, 0 into 0 is 0, 0 into 0 is 0. Here, 0 into 1 and 0 into 1 will also be 0, that I have written 1. Sorry for this. So every time when you fill the column, you have to cross check it. It's better so that you will not make any mistake. Now I'm cross checking S and W. 0 0 0 0 1 0 0 0 0 0 1 0 1 0 0 1 and 1 1 1 and 0 0 1 and 1 is 1. Remember to do the binary multiplication since it's an AND operator. Now let's do for the condition number 3. Condition number 3 says you have to do AND operation between not T and W. So just write down not T or T bar values in front of T. Make it 1 if it is 0 and make it 0 if it is 1. We have done with not T. Not T and the values of W here, these two columns will be multiplied. So 1 into 0 is 0, 1 into 1 is 1, 0 into 0 is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 is 1, 0 into 0 is 0, 0 into 1 is 0. Perfect. So we are done with all of these three conditions. Now for the fourth column, what you have to do, you have to perform OR operation between these two conditions. Look at this. In the logical expression, I'm just cleaning all to make it clear for you. The column 4 will be this one. It means that the condition number 1 will have an OR operation with condition number 2. So that you will be having the result here. So look at this. Just quickly do that. 0, 0, 0, 0, 0. Now, this is an OR operation. OR means that it is a plus. Addition of binary addition between these two columns. 0, 0, 0. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 1 plus 0 plus 1 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Okay, finally, for the last one, you have to do the OR operation with the result of 4. It means the result of this is column 4. And the column 4 is going to be OR with the third condition or 3. There will be an OR operation between them. So let me say that this and this are going to be added. So let's quickly do that. 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 0 plus 1 is 1, 0 plus 0 is 0, 1 plus 1 is 1, 0 plus 0 is 0, 0 plus 1 is 1. So here we go. These are the following conditions where the value of x is 1 and where the wind turbine will shut down. Okay, so stay tuned, stay connected. We are done with example number 7. If you have any questions, you can comment below so that I can answer you. Take care. Bye-bye. See you in the next video.